I'm going to discuss the adhesional wetting. So let's consider an example. Here we have liquid 1 and liquid 2. So each liquid have two types of forces known as cohesive forces, like L1 have work of cohesion with L1 and L2 have work of cohesion with L2. So for in order to calculate the work of cohesion, we have the work of cohesion here. For example, for the case of liquid 1, which is already occupying a surface and that is acting as substrate. So work of cohesion will be the interfacial tension for the liquid 1 and for example, this one is calculated for the case of L1 is occupying the surface of L1. So overall work of cohesion is equal to the twice of the surface tension of L1, whereas the work of adhesion is given by this formula. So for this case, spreading is actually the work of cohesion and work of adhesion. So work of cohesion is this one. It means that that is based on the cohesive forces between L1 and L1, whereas the work of adhesion is based on the interaction between L1 and L2. This is between two different liquids. So overall spreading is a sum of work of cohesion and work of adhesion. So here the total expression for the spreading by combining the work of cohesion and adhesion is the same as we have discussed before. An example of adhesional wetting is in the ships. The surface of the ships is covered with adhesive material which prevent the spreading. It means and this example is showing the type of adhesional wetting. This formula is for the application of spreading, but for the case of adhesional wetting, the value of liquid surface tension, this factor is lost in case of adhesional wetting, whereas for the case of spreading, this factor is negative and produced. So for the adhesional wetting, value of the spreading coefficient must be negative or it can be 0. So final expressions we get here for non-spreading or adhesional wetting, we have the formula that is the same as that was derived for the spreading, but here this negative sign is changed with the positive one. So overall, for spreading wetting, this value should be 0 or either it can be negative. So here we have example: dip a waxed paper in water and remove it. A water film will be formed and its surface that will immediately rupture into water beds. On the other hand, the same waxed paper is when removed from the oil from film will spread and become very thin without the formation of oil beads. So can you tell me which one is the spreading and the other one is which one is adhesional wetting?